Hey fifth graders, welcome back. We are on lesson 77 today. Love that number 7, one of my favorites biblically because, 7 days of creation, perfection. And today in lesson 77, we're going to talk about measurements for weight. Now remember, weight is the amount of pull or gravitational pull on an object. So when we talk about weight, we're talking about weight on Earth, because if we were going to Mars or we were going to the moon or any other place, the gravitational pull of that planet would be different. So our weight would be different. Our mass would be the same. We're still made up of the same stuff, but our weight would be different. So what we're looking at today is our weight on the planet Earth. And here are some conversions I wrote down. They're also in your book on page 499, but they're things that we're going to use, so I want to have them right in front of us here. So 16 ounces equals 1 pound. And again, we're talking measurement of solid objects. We're not talking about fluid ounces of water or any type of liquid like that. So when you think about 16 ounces in a pound, you can think about, okay, at age 16, I get my 1 license to drive, right? I have to be 16 to drive that 1 car. So you can kind of think of it that way to try and remember that 16 ounces in that pound. I want you today sometime go in the kitchen and see if you can find something that is measured as a pound, or maybe something that would equal 16 ounces. So if you have something like, maybe you have a bag of, raisins and it says that it's 10 ounces, then see if you can find something that's 6 ounces, and together you'll know what that pound feels like. Okay, so try and figure that out. Now I don't want you to try and find something that's 2,000 pounds, because that's actually a ton. When we say something weighs a ton, we're actually saying it weighs 2,000 pounds. 2,000 pounds equals 1 ton. And that's the abbreviation for the standard U.S. standard ton, TN, for a ton. Okay, so a metric ton that we're going to talk about in a minute has the lowercase letter t. That's why we use something different, so we know we're talking about the U.S. measurement of ton, not the metric unit of ton. Okay, 2,000 pounds is a ton. There are many different things that deal with tons, like the amount of food that an elephant might eat in a year, or the weight of an elephant. We might be talking a couple tons for an elephant's weight. So we use ounces, pound, and tons for the unit weight of the U.S. system. We have ounces, pounds, and tons. Okay, that's what we use in the U.S. Now, we also use these metric system units as we look at medicine, as we look at science. We use more of the metric system because it's universal. The United States, and there's only like 1 other country that still uses this units of measurement. Europe, Russia, China all use these metric systems. And so we're going to take a look at these, try and kind of come into our heads, what does that look like? Okay, so we have 1,000 milligrams equals 1 gram. The basic unit for measurement is the gram. Okay, so it's the gram. That everything that they have in the metric system revolves around that gram. So we have 1,000 milligrams equals 1 gram. Again, if the gram is the base unit, and I have milli meaning 1,000, right? A millennium, 1,000 years. We have a millipede. They talk about 1,000 legs, or walks like it has 1,000 legs. Those types of words that have milli mean 1,000. So 1,000 milligrams equal 1 gram. These are very tiny. Milligrams are very tiny. A gram, if you remember those little cubes that we used for covering up our numbers, and they were those little 1 by 1 squares, those are gram cubes. Those weigh a gram. So you're talking at like 3 paper clips. If you were to hold 3 paper clips in your hand, you're holding about a gram. Go to your kitchen today and try and find something that's measured in grams. That might be a little bit more difficult to find. I would look at things like spices or sugars, or something of that nature that you might find grams. Okay, 1,000 grams then, that base unit, if I have 1,000 of those, that's going to equal 1 kilogram. And a kilogram, when we look at what a kilogram is, for us to kind of think about it, it's actually about 2.2 pounds. So 2.2 pounds is about a kilogram. So if you can find something in your kitchen or your house that's a little over 2 pounds, that's 1 kilogram. When you go to the doctor's office and they weigh you, they'll usually weigh you in kilograms. So if you're trying to figure out your weight and you're like, I don't know how much I weigh, because they're saying it's so many kilograms, just multiply that number by 2 to get a rough estimate. 2.2 is to be more specific. So if you go to the doctor and they say that your weight is, let's say, 60 kilograms, if they say it's 60 kilograms, we just multiply that by 2.2. And because of the commutative property, I would flip it over so I can have that 0 in the corner. Remember how we could do this? We can drop that 0 off to the side. So we're going to drop that 0 off to the side. 6 and 2 is 12. Carry my 1. 6 and 2 is 12 plus 1 more is 13. I have 1 number behind the decimal place, so I should have 1 number behind the decimal place. So that means you'd be about 132 pounds if you were 60 kilograms. So you're obviously less than 60 kilograms, all of you in 5th grade. So you can kind of try and figure out, well, what would my weight be in kilograms if you were looking at your own weight. Try and figure that one out. Weigh yourself on the scale, and then what would you have to do? If I was this, then I'd have to divide by 2.2 pounds, which we won't get into now, but it's kind of a fun thing to try and figure out. How much do I weigh in kilograms? So look for something that's about 2.2 pounds and you'll find out what a kilogram is. 1,000 kilograms equals 1 ton, 1 metric ton. So they have those nice thousands here. 1,000 grams equals a kilogram. 1,000 kilograms equals 1 ton. So when you're doing that conversion, think about that thousands. What is a metric ton? A metric ton is about 2,200 pounds, so it's a little bit bigger than the U.S. standard pounds, or ton, sorry. It's a little bit bigger than that U.S. standard ton. Okay, so those are our units of weight. If you have your math notebook with you, you can write those down in there. If you don't, you can go back to page 499 and look at that chart when you need to. Eventually, you'll have those math notebooks back in your possession. So when you do, go ahead and keep your notes in there, even though we're going to be doing distance learning, because it's going to help you quite a bit as you go through things, and you're not going to have to be flipping through your book and trying to find, oh, wait a minute, where is that chart? If you write your own chart down in your math notebook in the section where we were kept taking notes, that's going to help you to keep that going. Okay? So let's just look at some conversions and what we might do. So let's say, like your example one, it says a large elephant weighs 4 tons. Okay, elephant, 4 tons. about how many pounds would that be? Well, I look back at my chart. It says 1 ton equals 2,000 pounds. So for every one of these, I have 2,000 of the pounds. So I have 2,000 pounds times that 4 tons. And when I do that, I have 8,000 pounds. Okay, so we have, again, to think about that, if I have 1 ton equals 2,000 of these, then I have 4 of them. I have 4 groups of 2,000. So 2,000 times 4, or 2, 4, 6, 8, 8,000. Okay, so when we look at that one, we just multiply it by 2,000. All right, number 2 says Boyd's watermelon has a mass of 6 kilograms. The mass of the watermelon was how many grams? Well, 6 kilograms. All right, and we want to know how many grams. 6 kg equals blank g. All right, so I go back up to my handy dandy chart, and I'm looking for kg and g. Kg and g. There it is. So if I have one of these, I have 1,000 grams. So I know my number is going to be bigger. So I want to say, okay, look at the relationship. What's the difference here? I have a 1 here, a 1 here. And then for grams, I have 3 zeros after it. So all I'm doing here is multiplying by that number, or however many I have, or I'm just taking and adding those 3 zeros to the end of my kilograms. So here, if I have 6 kilograms, then that means I would have a 6 with 3 zeros behind it and have 6,000 kilograms. Mathematically, we've taken 1,000 grams, because that's how many are in 1 kilogram, but I have 6 kilograms, so I have to multiply it by 6, 0, 0, 0, 6, and I have my grams. So 6,000 grams. Either way, I'm getting that same answer. Okay, look at your conversion. What is the relationship between the two? Now pounds and ounces are a little bit different with that. So let's take a look at pounds and ounces. It says he uses 2 ounces of cheese on 1 sandwich. If he makes 16, okay, so 2 ounces for 1. He's making 16 sandwiches. And the question asked how many pounds of cheese. Now how many ounces, how many pounds? So you want to know the number of pounds of cheese used. So first we're going to start with the 2 ounces and the 16 sandwiches. 2 ounces and 16 sandwiches. So I have 16 sandwiches times that 2 ounces, right? Because when I do that, I'm trying to figure out how many ounces of cheese I've used. So 6 times 2 is 12, carry our 1, 2 and 1 is 2, plus 1 more is 3, 32 ounces of cheese. But I need to find out how many pounds that is. And it says there's 16 ounces in a pound. So I want to know how many 16s can I get out of that 32. And that's actually 2, and we'll get 0, so I use 2 pounds of cheese in that one. Okay, so we have to look at first finding the ounces and then finding the pounds of cheese. Okay, one last thing quickly. Example number 4, Mr. Harrison's truck had a cargo capacity of about a metric ton. He had 3 containers weighing 156 kilograms, 127 kilograms, and 149 kilograms. Will the weight of the containers overload the truck? All right, so quickly we have 1/2 of a metric ton. 1/2 of a metric ton. Here's a metric ton. It says there's 1,000 kilograms in 1, so we have 500 kilograms in half a metric ton. See how I got that? 1,000, cut it in half because I have half one. So that's where I get that 500 kilograms. Now when we add those things up, we have 156. We have or 150, no, 156, 125, 149, 127, 149. Okay. Now we can estimate this by rounding it up each one and see if it'll overflow, or we can just add these three together and find out. But it says about a half a metric ton. So if it's close to a half a metric ton, we should be good. So we can add these up. 9 and 6 is 15, and then add our 7 to that, and we have 22. And then we have 7, 8, 9, and 4 more is 13. 1, 2, 3, 4, 432 kilograms, which is less than 500 kilograms. So no, it would not overload it. If you look in your book, what they did was they rounded this to 150. They rounded this to 125. And they rounded this to 150. So we have those nice numbers of only 5s to deal with. And they added those up and they got 425. And both of those, you can see how close they are. So you can use either way to find that answer, unless it told you to estimate. And if it told you to estimate, then you would have to do this thing over here where you rounded each one. And you could round that to 160 even, and 130 and 150, and then add those together. So anyway, that's the lesson for today, and hope you guys are doing fine. You have your worksheet there to work through those problems, and if you have any problems, don't hesitate to get a hold of me.